yeah, welcome everyone to this latest Zero Carbon Mine webinar. I'm Brett Dunstone, founder of Zero Carbon Mine. Yeah, and we discuss everything around the decarbonisation of the mining industry. Today we're talking mine electrification with Sarah, but anything and everything. So if you've got anything interesting to share in that space, please get in touch and see if we can put something out there. But without any further ado, I'll hand over to Sarah to introduce herself and share what she's got to share with us today.
Thanks very much, Brett, for the opportunity, and thanks everyone for coming along. Hopefully you can hopefully you pick up some interesting information that helps you with your decarbonisation journey. My name's Sarah de Vries. I'm a principal consultant at Snowden Optiro. I'm a mining engineer, not an electrical engineer, so don't ask me any too tricky questions. I sort of fell into electrification when I was working in Zambia, running some mining projects, and one of those was trolley assist. So I ended up spending 4.5 years over 2 different mines, designing trolley assist ramps and commissioning new trucks, which was really exciting and something that we have no trolley assist in Australia. So it was great to get the opportunity to be involved in that. And since coming back to Australia, I've did some work for Fortescue as well, looking at trolley assist in combination with battery electric trucks. And then I went back to my underground roots and did a study at IGO, looking at electrifying the Cosmos mine in Western Australia. So that's my background, and yeah, I'm all about electrification. You can't shut me up. So yeah, anyway, I'll get started, and hopefully there's some interesting things in here for you. So one of the questions I get asked a lot is, everyone's got these big plans. Are they actually achievable? What's the time frame, and how much are these things actually going to cost? So we'll go through and just give you a bit of a background and then talk about the details. Once I get my screen working, there we go. So we'll just have a general look at the decarbonisation of the mining industry. So why are we even talking about electrifying mining? And then I'll just do a quick run through of current technologies that are available, and then look at emerging technologies in mine electrification. Then I'll have a quick talk about infrastructure requirements, because electrifying a mine makes life a lot more complicated than a simple diesel mine. And then I'll have a look at what it will actually cost. So yeah, let's get going. So everyone's probably seen this quote. It gets tossed around a lot, but yeah, 8% of global carbon emissions come from mining, and 40 to 50% of that are from diesel combustion. So obviously the majority of that is from haulage in open pit operations. That's because we move ore and we move waste, and we usually move a lot more waste than we do ore. So in terms of distribution between open pit and underground, open pit is where the really big problem is. So yeah, how can we reduce our diesel usage, particularly in open pit mines? If we look at the world as a whole, where do we actually use fossil fuels? Okay, so power generation is a big one, and particularly in the Northern Hemisphere, heating, particularly in winter, obviously, and then cooling in WA and other parts of Australia. We know a lot about cooling. Transportation is a big one, particularly road. Again, in Australia, we're pretty guilty of that. We've got some massive distances to cover. And then industrial processes like, smelting of ore, creating steel, etc., etc. So what are our alternatives to fossil fuels? So the first prize for most people at the moment is renewable electricity generation. Countries other than Australia are a lot more fortunate. So if we look at Canada, for example, they have a lot of hydropower, which has no carbon footprint. The same in some Southern African countries. We don't have a heap of hydropower in Australia. Sorry, I assume most people are from Australia. So I am going to have an Australian focus. So yeah, in Australia, we're looking at things like solar, wind, a little bit of hydro is being considered. And nuclear is obviously the one everyone keeps talking about, seems to get a lot of political discussion. So everyone's got an opinion about that. But yeah, if we're looking at it from a carbon generation perspective, nuclear is actually a really good option. Problem with renewables is the sun doesn't shine all the time, the wind doesn't blow all the time. So how do we even that load out? So looking at storage of that renewable energy is really important. And that's where all the improvements in battery technology over the last 10 to 15 years are making it really exciting and possible to start storing some of that renewable generation. And then we've got things like hydrogen, ammonia. We see lots of stories, but we're not actually seeing them being used commercially to a large extent yet. So yeah, but if we're looking in mining, we generally have a quite a long time frame. So all because it's not available off the shelf today doesn't mean it won't be in 5 or 10 years' time. So it's important, I think, to keep our options open to all of those things. So if we move away from power generation and we look at actual mining operations, how can we actually reduce our fossil fuels? So sorry, this is a really wordy slide, but I wanted to spell out all the details there. Okay, so the fossil fuel power generation we've just talked about, and those battery energy storage systems are super important. So the big usage is with truck haulage, particularly in open pit. So we can remove diesel consumption totally or reduce it by using electrification technologies that are currently available. So we've got things like in-pit crushing and conveying, where you have a crusher inside the pit. So your trucks don't have to haul very far. They dump into that crusher and then conveyors take the ore or the waste out of the pit. Not used terribly often around the world. There's lots of constraints on that. A bit more common is EPCC, which is ex-pit crushing and conveying, where the trucks come out of the pit and then tip into the crusher. Rope con is another variation. I've got a picture of that later. Rail veyor, and then trolley assist truck haulage, as I mentioned earlier. Loading equipment is another way. So diesel diggers, excavators are really easy to move around, really flexible, but yeah, they also consume diesel. So we can replace that diesel loading equipment with cable electric equipment, shovels, excavators, or even tethered underground loaders. All of these things have been around for decades. We can also reduce our diesel consumption by replacing our diesel trucks and loaders with diesel electric trucks and loaders. So it sounds, they're a bit more expensive to buy, but the technology is available now and has been available for a long time. And you can reduce your fuel consumption by up to 30%, depending on your haul route. Drilling equipment, again, off the shelf, electric drills, replace your diesel drills with electric drills, available now. An emerging field is replacing diesel with biofuel or renewable diesel. There's some sustainability and ethical considerations that go along with that, but that is an option, an expensive option, but an option. And then there's a whole heap of things that if we mine more efficiently and have less idling and less wastage, we can reduce our diesel consumption there. So things like remote health monitoring, fleet management systems, mine planning systems, and AI, decrease queuing and our idle time, reducing rehandle. So for those mining engineers on the call, you know, things that we should be doing to save money, also actually reduce our carbon consumption, reduce our diesel consumption. So I'm going to run through all of these in a bit more detail and then talk about, you know, the new technologies, which is our battery technologies. So in terms of decarbonisation pathways, I've got a couple of different examples from some of the big mining companies in the world, and it's quite interesting to see the different paths that these companies are taking to reduce their carbon footprint. So this is BHP's, I think this slide's from last year, and it's a pretty detailed slide, but you can see the thing they concentrated on from 2020 onwards was basically replacing their power generation with renewables in South America primarily. South American operations are very haulage intensive. They often have to desalinate seawater to supply their operations. There's lots of pumping involved. So you can see this big, I don't know if you guys can see my mouse, but you can see this big drop off here where they've managed to replace their fossil fuel heavy power generation with clean power. So that was their first prize, and they've been really successful doing that. And then you can see mine electrification, actual electrification of operations. There's not actually much that they're planning to happen there up until 2030. So there's lots of trials going on with electric excavators, electric trucks, electric locomotives. But yeah, it's a long road, and that's because that technology is not commercially available yet in the open pit situation, which is where the bulk of BHP's carbon generation comes from. Okay, so that's one way of looking at it, and there's a few smaller mines in WA who are doing the same thing in terms of building renewables to replace their, diesel or gas-powered power plants. Rio Tinto have gone down quite a different route, and it's not because they don't believe in mine electrification, it's because they are aware that the technology is not readily available yet and it has a development period ahead of it. So they're really going for the renewable diesel approach at the moment. So they've done some trials and they've fully implemented boron and Kennecott now are using renewable diesel. This is expensive. There's no doubt about it. And I think we also need to be careful that we're not replacing, agricultural land for food generation with diesel generation. So it's a little bit dicey in that perspective, but that's the route that they're going because they can't go and buy electric trucks off the shelf at the moment. And then we have Fortescue. So Fortescue have gone hard the other way from Rio Tinto, and they're actually heavily investing in bringing that technology to the field and developing it. And there's been some quite interesting news from Fortescue in the last few weeks. This wasn't part of my original slide. Sorry, I should have said I did this presentation originally for the AusIMM Sydney branch in July. So, but there's been a few changes. So, but Fortescue actually bought their own technology company, which was Williams Automotive Engineering in 2020. They are a battery electric vehicle company. They race in the Formula E. So Fortescue actually purchased that company with the intention that they would develop their own battery technology to power these big 240-tonne trucks. Obviously, building a battery that big is pretty complicated and hasn't been done before. So they saw the need and they went out and bought this technology company. The things have changed a little bit now. So they had an arrangement with Liebherr. So Liebherr were supplying the trucks and Fortescue were supplying the batteries to go into those trucks. Because battery technology has come along so quickly in China in the last 3 or 4 years, they've now made the decision to actually source their batteries from China. I think it's from Cattle. So they're no longer going to build their own batteries in the UK, and they're going to get the batteries from China. And they're also getting some battery trucks from China now as well. So they're splitting their order between Liebherr and XCMG. They've also been testing ammonia power for shipping and hydrogen fuel cell trucks. They're replacing their trucks with battery electric trucks, and then cable electric shovels, cable electric drills, and a variety of other supporting equipment. So we've all seen their slogan of Real Zero by 2030. So they're actually making big efforts to get there and investing heavily in doing that. So there's 3 of the bigger companies and what they're doing. So there's quite different routes. Some are a bit more safer, a bit conservative, and some are really pushing the boundary. Moving on from decarbonisation, though, there are other reasons to electrify mining. So why would we think about it? And this has been a bit of a change. So obviously the political environment in the US has changed in the last year. The sustainability decarbonisation message has been a little bit muted. So people are coming back to the dollars, to the financial reasons for electrifying. And there are lots of reasons to do that. Electricity is a lot cheaper than diesel. Maybe not in the Pilbara in Australia, where we're in the middle of nowhere and we have to generate our own power with, at the moment, diesel or gas. But if you're in a low power cost jurisdiction, it makes a lot of sense to swap over to electric mining rather than diesel mining. For example, when I worked in Zambia, we were getting our diesel shipped in, trucked in from the coast. So we're a completely landlocked country. So getting diesel to site was actually a really big logistical exercise. Power was simpler and cheaper. On top of that, electricity is more efficient than diesel. So when we run our trucks on diesel, that diesel's only about 30% efficient. We lose a lot to heat, so we're throwing our energy away there. Electric motors are about 90% efficient, so we're already making a massive saving there in terms of actual work that we're getting out of our power source. Electric motors, we get a massive speed increase, particularly on ramps. So trolley assist trucks, which are a readily available technology, you'll generally get 80 to 100% improvement in your speed on a ramp. You should achieve that underground as well if you had a trolley assist truck, as long as your ramp condition is reasonable. If you've got big rocks everywhere, that's going to slow you down. But yeah, it's a quite substantial speed increase on what is generally a very slow part of the haulage cycle in mines. The maintenance of electric vehicles is much easier and cheaper. There's far less moving parts. So yeah, maintenance costs are expected to reduce substantially. On the other side, you do need some different skills and different people to look after your batteries. So yeah, there's a bit of a give and take there, but it's expected on the whole that the costs will come down. And the big win for underground is that by removing diesel equipment from your underground environment, you're not generating, so all of that heat that's lost from inefficient diesel actually heats up your air. And that's one of the reasons we, particularly in Australia, need a lot of cooling. So if you're not adding all of that extra heat to your mining environment, you can significantly reduce your cooling costs, and you can also reduce your ventilation costs in terms of your primary ventilation quantity. On top of cost benefits, we've also got some significant safety and health benefits as well. So working conditions improve. You're not working in the heat anymore. The environment is much quieter. You're not getting the same whole body vibration that you get sitting in a diesel loader or a truck all day long. In cases where mines are located next to towns, the reduction in noise is actually really important and really a big plus for electric equipment. And there's a whole heap of, health benefits that you get from removing diesel, no more exposure to DPM and so on. That improves the safety and the health of workers. So there's some other really good reasons apart from decarb and from cost. So let's have a look at the current technologies that are available. So for an open pit, you've got things like in-pit crushing and conveying. This is one of the in-pit crushers at Sentinel Mine in Zambia. So the trucks tip in the top here, it gets crushed, and then it gets loaded out of the pit on a conveyor. Again, Zambia is a very low-cost electricity environment. The power comes from hydropower, so it's extremely a sustainable solution for them. This is another version similar. This is a rope conveyor at Media Luna mine in Mexico, and it's a similar sort of thing. So the pit's actually up here, and it then gets taken down to the plant down the bottom here. So yeah, they're both really good examples of current technology available for electrifying mines. So that's actually removing truck haulage out of the equation almost completely. Trolley assist. So again, this is a technology that's been around for 50 or 60 years in various iterations. basically when the truck, this is a diesel electric truck, so as the truck comes to the bottom of the trolley ramp, it raises the pantograph here and starts drawing electric power from the overhead catenary wire. So that truck then basically switches off the diesel motor and converts into running off electric power. So the truck gets a huge boost in speed. So on diesel on ramps, you're typically running about 8 to 10 kilometres an hour, and on trolley, you'll go up to about 18 to 20 kilometres an hour. And the noise just drops away, which is actually quite amazing to watch. You know, you've got this massive noisy diesel truck, and then the noise just disappears. So some big advantages there. So disadvantages for trolley assist, obviously, you need all of that infrastructure to go in. That's costly, and there's a whole heap of supporting electrical infrastructure such as a substation, transformer, DC rectifier that's required to power that line. So it's not an insignificant investment to put a trolley line in. There's a whole heap of other electric equipment that's been around forever. So we've got drag lines in coal, we've got electric face shovels, electric excavators, electric production drills. So that technology is fully proven. It may just require some changes to operating practice from a typical diesel mine. One of the big issues that's been in the past is how to move this cable around. Particularly in Australia, we don't tend to have heaps of people spare to move cables around, and this is a manual handling risk as well. So it's really good to see these cable reels coming in now to minimise that. And that also helps with the old problem of running the cable over, which happens more than you would hope. There is an operational implication in that it is a bit harder to move your diggers out of the blast radius, and depending on your supporting resources to move those diggers, you can lose quite a bit of productive time moving the diggers out of the blast radius. Underground electrification options, shaft hoisting, been around forever. Again, very capital intensive at the start of a mine life. So you need a mine with reasonably long life and reasonably high tonnage to justify that expenditure. That's a very effective electrification technology. Similar to IPCC, you have a crusher that breaks the ore up into a smaller size and then it gets hoisted up the shaft in skips. Battery electric locomotives, if anyone's ever been to an older mine, they often used to have railway haulage loops down the bottom and they were running off lead acid batteries. Tethered electric loaders have also been around for, I don't know, 20 or 30 years. You can see the cable reeler on the back there. Typically used in large quantity fixed routes, such as transferring from the bottom of an ore pass into a crusher. And then you've got trolley assist haulage. Kirina trucks, again, have been around for a long time. They were at Mount Isa. So this is actually quite a funny story from a decarbonisation perspective. So the trolley assist would run on the ramp, and then they had a very small battery that allowed them just to go off the ramp to get loaded. And they were eventually replaced with diesel, those batteries, to expand the tramming distance that was possible. So yeah, that's a reverse decarb decision. So what are our new technologies? So lithium-ion batteries, battery electric vehicles are becoming much more readily available. We're seeing it on our roads now, probably not so much in Australia, but certainly places like China, they're becoming very, very, very common. Why is that happening? You can see on this graph here how the price of lithium-ion batteries has come down since 2010. That's a really quite astounding cost change in that time. And then now you can see as well in China how the pricing is comparing to internal combustion engines. So from a mining perspective, why are battery electric vehicles now becoming a possibility? Cost is coming down, as I said. The capacity and the range is increasing. So Sandvik, one of our main underground OEMs, are already up to their 3rd generation battery. So the battery capacity increased about 35% with the last iteration. So that's expanding the range of these vehicles and making them more suitable for most operations. The other big advantage of battery electric vehicles is the fact that power is generated by braking. And because we're in a battery electric vehicle, we can actually store that power back to the battery. So in addition to being far more efficient than diesel, we're actually generating some power as well, which is very cool. And then battery swapping. One of the big disadvantages of battery electric vehicles is having to charge. So it doesn't make so much of a difference to us when we're driving a vehicle on the road, but when we're using a heavy vehicle 24 hours a day, 7 days a week, ideally, having to brake frequently to charge that battery actually really eats into your operating time. So one of the good things that's happening is battery swapping. So instead of having to stand in one place and charge the battery and losing the use of that piece of equipment, we can now just swap the depleted battery out for a fully charged battery. So that's happening underground, and I actually just read this morning that Rio Tinto have successfully kicked off their trial of battery swapping technology in Mongolia in the open pit. Relatively small trucks, only a 90-ton truck, so not the big ultra-class trucks, but that's a really exciting first case in the world of battery swapping in an open pit operation. I just want to quickly talk about battery chemistry because everyone seems to get hung up on different battery chemistries as being more or less safe than others. I think it's just important to realise that chemistry is not the only component of safety, and choosing a chemistry for a battery underground in particular is based on a whole heap of other factors as well. So specific power and energy, cost, lifespan, performance. So for example, LTO batteries on this side, they're they're great. They're very expensive. They're very, very safe. They've basically got no chance of having thermal runaway, but they're very heavy. So they're not really suitable for use in a haulage vehicle because you're taking up potential payload with battery. This kind of battery is typically used by auxiliary equipment. And then for our haulage equipment, you're looking at either lithium iron phosphate or NMC batteries. And they're both used. So Epiroc haulage, they use NMC, and Sandvik use LFP. So yeah, it's really just important to realise that chemistry is not the only component of safety, and you would actually make that choice based on a whole variety of reasons. And safety, I'm just going to preempt this because this is the first question that generally comes up. I did a talk yesterday and it was the first question. What about battery fired underground? I think it's just important to realise that the batteries that we're using underground are not like the batteries we've got on our electric scooters or skateboards or whatever. These are very highly engineered with multiple levels of safety protecting those batteries. I'm not aware of any cases that were not due to human error of thermal runaway in battery electric vehicles underground. It is very true that once a battery goes into thermal runaway, that it is very difficult to put out. It needs to be drenched in water for 24 hours at a minimum. So yes, there is a concern there. But yeah, I think we need to realise that there's a whole layer, multiple layers of safety that are protecting those batteries. It's not to say there's not a risk, there's absolutely a risk. But yeah, sorry, I just see that comment coming through. BEVs are far less likely to catch fire than diesel equipment. So for anyone who's been involved in a diesel fire underground, it's a really horrible experience. So the fact that we reduce that likelihood of that happening is really important. So BEV trucks, so this is the Sandvik 50-ton truck. So I mentioned this earlier, but you've got your increased speed on grade. I don't think you're going to get up to 100% speed increase on an underground mine, but I'm certainly hearing stories of 50 to 70% speed increases on ramps, which is awesome. Loaders have a faster dig speed, so you're getting a time advantage there. You're saving power to your battery, you're reducing your maintenance costs. The main limitation at the moment is battery capacity is not large enough to allow haulage from very deep mines. So if you've got a reasonably shallow mine, say 400 to 500 metres below surface, that's perfect for battery electric trucks. If you've got an 800 or 900 metre deep mine, you won't be able to haul all the way to surface on one charge. If you've got a mine that deep, though, I would hope you'd be looking at things like conveying or hoisting anyway. I won't go through this slide in detail, but it's just to show you that you can basically, if you wanted to, you can set up a fully electric underground mine right now. All of those different equipment types are available commercially. They may not be available as quickly as diesel equipment. The lead time is a little bit longer, but there are multiple mines around the world now that have placed orders for fully electric fleets, and they're implementing them at the moment, which is really exciting. The other big benefit, as I mentioned earlier, is ventilation and cooling. So by removing diesel from our underground environment, we're removing that exposure risk. DPM, diesel particulate matter, is a class 1 carcinogen, and we should be making all efforts to remove that and remove people's exposure to it. The Safe Work Australia limits are dropping by a factor of 10 at the end of 2026. So that's another reason, apart from minimising our workers' risk to their health and safety, it is actually going to be a regulatory limit as well. I won't go into ventilation too much, but at the moment, one of the main ways we work out how much ventilation we need underground is based on the amount of diesel equipment we have underground. So we have a factor generally about 0.05 cubic meters per second per kilowatt of engine capacity. So if we don't need to dilute those diesel fumes and diesel emissions anymore, we can actually, hopefully, we believe, lower our primary and secondary ventilation quantities. Obviously, it depends on the specific mine. If you've got a very hot mine, you might not be able to reduce it as much. But if you can reduce the size or the number of primary vent raisers that you need, that's a very significant cost saving, and it can quickly offset the increased capital cost of BEVs. And similarly, if you can reduce the amount of air you need at the face, say if you have a truck and a loader operating, you normally need about 42 cubic meters per second, and that drives the size of the fan and the ventilation ducting. If you don't need that much air anymore, you can drop your fan size back, you can drop your duct size back, and you can theoretically drop your development size back as well. So again, there's a cost saving there. Heat generation. So studies in Canada have shown that a diesel loader puts out an extra 3 to 4 degrees of heat around that loader. In the same situation, a battery electric loader didn't raise the heat at all. So if you think about all the pieces of diesel equipment you've got running around underground heating up your air, you can actually, remove that completely and make the working environment much better and save a heap of money on cooling. Diesel electric loaders and trucks. Despite the fact that diesel electric trucks have been around in open pit for a very long time, they're just coming into the underground environment now. The CAT 2900 XE has been very successful, and Sandvik and Epiroc are now both releasing or trialling prototype 65-ton trucks. It's quite funny that they released the BEVs first and they're now going back to diesel electric. And I think the reason for that is the prospect of going battery electric is very, very intimidating to a lot of people, both from a cost perspective and an experience perspective. And this is a good entry point. You do get some fuel savings and you get some experience with electric gear. So interesting to see those trials proceed now. Open pit BEV trucks. So battery electric trucks are very common in China and Southeast Asia at the moment, but these are the small size trucks, 70 to 90 ton trucks, but they are around, they're working really well. And that's just a sign of how the battery technology has developed so quickly in China. They're not yet available commercially in the sizes that we typically use in Australia, our ultra class trucks. So prototypes are being tested by Caterpillar, Komatsu and Hitachi. Same with Liebherr, but again, they're not developing the batteries. They're going to be supplied by Fortescue. These trucks are massive. These batteries are massive. It's a really ambitious undertaking to put batteries in these big trucks. So the state of technology readiness is still very, very low. We're really at the prototype testing stage. So if you wanted to fully convert your open pit mine to battery electric trucks, I would guess at the moment you're probably 8 to 10 years away from just being able to go and buy one off the shelf. I think given that a lot of the OEMs are now realizing that the ideal solution is not to have such huge batteries. So if you can run off trolley assist or the various variations of dynamic charging that some of the OEMs are developing at the moment, if you can directly, so there's two advantages to that. One is you can power your truck directly, and you can also recharge your battery for times when it's not attached to your trolley line or your dynamic charging line, without having to stop and statically charge. So dynamically charging your truck means that you don't lose that operating time or you're standing still and charging. There's other technologies around biodiesel, hydrogen fuel, ammonia, but yeah, they seem to be not developing anywhere near as fast. But yeah, they keep aware of those technologies as time goes on. Right, infrastructure requirements. So for all the miners in the room, we're used to just putting diesel in our truck and off we go, and we don't have to think too much about it. We'd fuel up once a shift, once a day, depending on our haul cycles. And we only lose sort of 10 to 15 minutes out of the day. So it's not really a big deal for us. We don't have to think about it too much. That will change with battery electric or electrification technologies. So for underground, this is what a battery electric charging station looks like. So this is a battery swap bay in Bruce Mine in Canada. So you can see it's a quite significant underground installation. Typically an underground mine would only have one diesel refueling bay. You are going to need more than that for charging. So we're looking at an expanded footprint in terms of development, electrical infrastructure, electrical power, ventilation. So there's definitely a cost involved there. And I mentioned it earlier that both underground OEMs have set up their trucks and loaders to be able to swap their batteries rather than statically charge them. Sorry, correction, Epiroc, you can either battery swap or statically charge, fast charge, whichever one you like. So how many times do we need to do that in a shift? So loaders, you're looking at least once to twice a shift. Generally, production loaders are operating on the flat, so it's a reasonably easy haul cycle compared to trucks, which are generally tramming uphill loaded, which is a much more energy-intensive haul cycle. So depending on that cycle, you can have to charge or swap your battery every 1 to 2 haul cycles. So that's adding up to 6, 7, 8 times a shift. So it's quite a big imposition. So ideally you want to locate those bays on your haul route or on your loading route to minimize the time you have to lose to go off and swap your battery. So that's why it's important to have a lot more battery bays than just the single refueling bay that we've traditionally used. And BEVs. So Fortescue have publicly said they're going to need to charge their batteries about every 4 hours on their 240-tonne trucks, and that charging will take 30 to 35 minutes. So despite the speed increases, you can see that you're going to start losing a really large chunk of your day to charge those trucks. So first prize is to dynamically charge those trucks while they're moving. So that is really in the last year, the big trend we're seeing coming from the OEMs looking at dynamic charging options. So Caterpillar and Liebherr have both got dynamic charging options. I'm sure most people have heard of Blue Vein, which is a really exciting charging technology that's being developed in Brisbane at the moment. And then you've also got your traditional trolley assist. So all of those options are going to coordinate really well with battery electric vehicles to charge. So when it comes to infrastructure, I've talked about charging and swapping stations. I think the big thing for open pit in particular is power availability. So even if you manage to remove diesel from your operations, you're then going to have to compensate and supply additional electrical power to those operations. So we're looking at a large increase in the power requirement at your site. So can you even produce that much power for islanded mines? Or can you draw that extra power from the grid? Is the power available? The other very big issue for traditional diesel open pit mines is electrical distribution. If you're running a diesel operation in the Pilbara, you probably don't have power lines running everywhere. The mines I worked at in Zambia were set up to be electric mines, and they had a really good distribution network set up for the trolley assist and the electric diggers. But many diesel mines, particularly in Australia, have power running to their plant and their administration area, and that's it. So if you're running a very spread out mine, you're going to have to put a lot of power lines in. So there's a big cost involved in that. There's a big labour availability issue involved in that, and a skilled labour availability issue involved in that. Generally not an issue as much for underground. Underground mines are established with a big distribution network because we need it to run our jumbos and to run our production drills. So not as much of an issue for underground. I've already talked about charging and swapping. Again, it's an extra expense that needs to be dealt with. The other issue for underground particularly is that we're going to need to manage our equipment much better than we do now. So we're going to need fleet management systems and electricity management systems to manage how much power we're consuming. And to do that, we're going to need a connected mine. Open pit mines now are generally all connected to GPS, you know where everything is. We're still not quite there yet underground. So there's a big investment that's going to be required there. And I guess on the other side, we can reduce our ventilation and cooling and infrastructure for underground. So that's a positive. What is it going to cost? It's not going to be cheap. So I can't give you truck prices for open pit because you can't buy them yet. For underground, you're looking at almost double to buy a battery electric truck or loader compared to a diesel one. And that's before you even look at the cost of the battery. And these batteries are going to be very expensive. Both Sandvik and Epiroc are offering what they call battery as a service, where they retain ownership of the battery and they look after the servicing of the battery. One of the interesting things about batteries is they don't last forever, depending on their use cycle, and they will need to be replaced. So there's an additional cost there that you don't have with a diesel piece of equipment. So that's battery as a service. Those costs are really significant at the moment, I think, because battery technology is new, and I believe that OEMs aren't that sure about how well their batteries are going to last. For the Cosmos study that I worked on, it was about 30% of the maintenance cost was actually just battery as a service. So it was very expensive. So yeah, everything's expensive at the moment, but if you can save, say, $50 million by dropping a ventilation raise out of your vent design and your mine design, you can actually quite quickly cover the cost. And I think it's really important to realise that your total cost of ownership should be lower over the whole life of the asset. And I think these prices will look very different in the next 3 to 4 years because battery prices are coming down so quickly. I won't go into this in detail because I can see I'm talking for too long again, but these are all the things you need to consider when you're doing your financial evaluation. And I just want to point out that it is very mine dependent. I mean, if you've got a really hot mine, it probably makes a lot of sense financially to look at electric equipment. If you've got a shallow mine that's not that hot, maybe not. But yeah, if you can save a lot of money on ventilation and cooling, then financially, it could be a really good decision. And this is before we bring, you know, the cost of decarbonisation, carbon pricing, etc., and achieving your company's decarb goals into the equation. This is a straight dollars comparison. So what's the conclusion of all of this? So our traditional electrification technologies are suited to low power cost, high production rate, long life mines, but they really do limit your flexibility. BEVs, which is our new mining technology, combine the flexibility of diesel with the environmental and cost benefits of those traditional electrification technologies. So underground BEVs have been in use for over 10 years now in Canada, and you can commercially buy BEVs to replace all diesel equipment underground. The main capability limitation at the moment, as I mentioned, is trucks. So if you have a deep mine, you're not going to be able to manage that full haul to surface on one battery. And as I said, capacity is going to keep increasing and the costs are going to keep coming down. So underground BEVs are quite an attractive option at the moment. Open pit BEVs, we're still some time away from being able to go and buy a battery electric truck off the shelf. I've said 5+ years there. I'd probably push that even more at the moment. Yeah, things aren't moving as quickly as we all hope they would. But what can you do to electrify your mine and save diesel consumption at the moment? So yeah, utilize all those tools you have already, your fleet management system, your planning system, even AI is starting to make a big splash. Run your mine efficiently and reduce your diesel usage. Even silly things, or not silly things, little things like road maintenance, making sure your roads are smooth and minimizing that rolling resistance. All of these things can pay off. I think we just need to be aware of underground BEVs. There aren't any mines that are fully electric in Australia yet, and there's there've been a number of trials of electric equipment done in Australia, but none permanently operating that I'm aware of. But particularly if you're looking at setting up a new mine or a new ore body, just be aware of the possibility of BEVs and include it in your initial studies, because it may make a big financial difference as well as a decarbonisation difference to your operation. And just, it's a case of doing the right thing. I think for workers' health and safety, we've got a regulatory and an ethical responsibility to our workers to provide them the best possible working environment, the safest possible working environment that we can. BEV trucks are not yet available for open pit, but diesel electric trucks are. So if you're looking at purchasing a new truck fleet, consider diesel electric. It's going to save you fuel and be better for the environment as well. And an interesting out-of-the-box thing that I heard at a panel I was on a few months ago, at the moment, a lot of mines with their closure requirements have to fill the hole back up at the end of the mine life. And if you think about how much diesel we use to actually do that, can we reduce our greenhouse impact by just not filling that hole in? So it's just a bit of an out-of-the-box thing to think about. And I guess just in closing, Australia is lagging Europe and Canada at the moment in terms of decarbonisation of our mining. And let's just have a think about why that is. There are some obvious reasons our government is not legislating as quickly as some other countries are. And we've also got a contractor culture where we push our contractors hard to get fast development rates, and we're not really incentivising them with our current contracts to decarbonise. So that's it from me. I'll take some questions.
Thanks, Sarah. I think there was a couple of questions as we went through there. Yeah, I think one, James, was, you're talking about out of the box thinking, sort of saying, if automation of haulage trucks can be done, could you see large numbers of smaller electric trucks, changing the paradigm? I know there's work that's being done. I think, is it Volvo, whatever, was that swarm sort of technology? Is there, how much interest or work is going on that sort of side of things?
I think people are looking at it, but there is a reason that we went to bigger trucks in the first place. But yeah, it is changing the trade-off now. So if you need to throw 8 or 10 tons away in battery weight, and then that reduces your payload, that might change your economic calculation as to what size trucks you want. But yeah, I didn't talk about automation in this talk, but yeah, electrification and automation obviously have a huge amount of synergies. So yeah, it's something that needs to be considered going forward. If you're going to go to the whole exercise of electrifying your fleet, why would you not automate it at the same time? Because it might make it a lot easier to manage. So
yeah, a lot of just making it all work more efficiently, like you were saying, automated, sort of taking the human error sort of out of things.
Absolutely. I mean, I'm sure we've all been on sites and we've watched a queue of trucks sitting at a diesel digger while the diesel digger gets fueled up, I mean, and they're all idling the whole time. I mean, there's so many things that we can do better.
There's one question from Jason sort of early on. The approaches you've indicated for BHP, Rio and FMG consider the wider system unlocks from decarbonisation, i.e. remote operations and the like. So I suppose, yeah, your thoughts or...
Sorry, say that again, Brett. What was the question?
Do the approaches you've indicated from BHP, Rio, FMG consider the wider system unlocks from decarbonisation, remote operations and the like? I'm trying to, yeah.
I don't fully understand the question, but I will say, I mean, I've spent some time looking into the safeguard mechanism, which is Australia's, primary, means of encouraging decarbonisation. As far as mining operations in Australia go, there's very few underground mines that are actually affected or covered by the safeguard mechanism. It's mainly the bigger, iron ore and coal mines that are actually covered by that. So in terms of government regulation, there's not a heap of incentive for, your mid-tier and your juniors to actually decarbonise at the moment. But you can see with those BHP, Fortescue, Rios, they are very definitely covered by that regulation. But apart from Fortescue, BHP and Rio are global companies, and do have global reputations to maintain, and decarb standards in other countries that they're trying to achieve as well.
Yeah, and also like diesel particulate matter standards, they're coming down in, I forget the year, but you see that should have an impact on at least underground mines taking up this sort of technology.
Yeah, I mean, look, this is a really emotive topic. So, so the limit is coming down by a factor of 10. I would question whether we can actually achieve that in diesel mines. So yeah, it's going to be an interesting time for the industry. We don't monitor DPM very well generally. We do tailpipe tests of equipment, but we don't actually monitor workers very well. And to measure DPM, the traditional way is to wear a monitoring device around, and that filter then gets sent off at the end of the shift and analysed in a laboratory, and then we get the results back a couple of weeks later. So it's not exactly real-time monitoring, and there are some continuous measurement devices available, but I haven't heard great stories about how effective they are. So number one, how are we even going to measure that we're achieving these new workplace exposure limits? And two, is it even possible? I don't know if it is. It's a very interesting time over the next year for us.
Yeah, no, it is a big it's a big drop, and yeah, whether or not
it's not just DPM. There's big drops in lots of other things as well. Carbon monoxide, etc. And the strategy seems to be taking those limits down as far as they can actually be detected, rather than necessarily whether there's proven health effects from them. So yeah, anyway, interesting times.
Yeah, and one question, Kevin not too long ago. Do you think the new 2025 Australian sustainability reporting standards will drive companies to move faster toward change once targets been set? Do you know much about that?
I don't know a huge amount about those new standards. I will just say, though, I do think there's a lot of willingness to do the right thing. I mean, you look at all the floods and fires we've had in Australia in the last few years. I think everyone's aware of climate change, and most people would like to do the right thing. But yeah, it's just not easy. Even renewables, I believe there's a 2-year wait for a crane to install a wind turbine in WA. So nothing's happening quickly. And you can see that with renewable rollout across the country. Nothing's happening as fast as we want. So it's not necessarily that we're not being pushed to do things fast enough. It's that the technology is still developing and the availability and the price is not there yet. So we've got a way to go.
Right. And you mentioned, the biodiesel, diesel thing. Like, what sort of premiums are you seeing on biodiesel at the moment? I know you're saying it's, it's probably one of those things that varies greatly, but
I think it's about double, but please don't quote me on that because my figures might be a bit out of date, but it is a lot more expensive.
Yeah. And there's all the other issues that come with it, not just the price.
Yeah, I mean, I can totally understand why Rio Tinto are doing it because they want to achieve their decarbonisation targets and they don't really have any other option at the moment. But certainly for a mid-tier or a junior company, I don't think it's easy to get hold of. And you're not replacing the whole stream either. So, yeah.
Right. Yeah. Any more questions out there? I might sort of just about an hour we've been going, so I think I might wrap it up unless there's any last minute ones, but I'll just do a quick. All right,
yeah, there's my details. So if anyone wants to chat further, I think this is a really interesting topic. If you've got any questions, I can't cover everything in an hour. So yeah, just get in touch.
Yeah, I'll just share. We've got another presentation coming up in a few weeks. Yeah, so another 3 weeks time, we've got our next webinar coming up with Peter on. He's a sort of tech resources manager of mobile fleet decarbonisation. So he's about the breaking through the adoption barriers and trying to get more. What do we need to do to get more technology from pilot projects to more widespread usage? So that should be an interesting one. Yeah, I think that's 3 weeks today. But yeah, I thought there was new questions, but yeah, I think there was just one from Will around, do we need to rethink mining methods? And yeah, I think that's part of what we need to be doing, which is probably easier said than done sometimes. But yeah, thank you. Thanks for your time, and thanks everyone for tuning in. And yeah, bye for now.
Thanks everyone. Thanks, Brett.